Okay, uh, children, today we are discussing first problem of joint entrance IIT advanced paper 1, first question. Okay, what does this question is saying that there are two functions. First, the function f maps a b to 1 to infinity. Okay, this is the continuous function given, and g is another function which maps r to r. Okay, and the gx is defined it like this, that gx is equals to 0 when x is less than a, and gx is the definite integral of ft dt when to the limits a to x when x lies between a and b including both. Okay, and gx is equals to the definite integral of ft dt to the limits a to b when x is greater than b. So there are four options of this problem, and out of these four options the correct may be more than one. Okay, the first option says that gx is continuous at x equals to a but not differentiable at x equals to a. The second option says us that gx is differentiable for all x equals to r. And the third option says that gx is continuous at x equals to b but not differentiable at x equals to b. And the fourth option says that gx is continuous, okay, but differentiable either at a x equals to a or b but not for both x or b. X equals to a or b, it is not continuous for both. It is either continuous at x equals to a or x equals to b. Okay, differentiable at x equals to a and or x equals to b, but it is continuous for both. Okay, now let us check these options one by one. Okay, so first I am checking the continuity of x equals continuity of gx at the points x equals to a and x equals to b. Okay, so the limit of gx, when x tends to a minus, okay, that means the value of x is less than a. So the value of when the value of x is less than a, the gx is equals to 0. It is given here. So this is equals to 0. Okay, and the limit of gx when x tends to a plus, that means the value of x is greater than a. So when the value of x is greater than a, what is the value of gx? It is given here. Okay, so this is limit of x tends to a plus. Okay, it is a definite integral of ft dt to the limits a to x. Okay, so here this is, in place of x I will put a. Okay, so this is equals to definite integral of x, I will put a, and here it is ft dt. Okay, so what will be this? This value will be, both upper and lower limits are same, so its definite integral will be equals to 0. And GA, so when the GA, so GA is what? When x value is equals to a, so this is the value of the gx. It is for x I will put a, here a f t dt. Okay, so this is also equals to 0. Okay, so what we are getting? So we are getting the limit of gx. So the limit of gx when x is tending to a minus is equals to limit of gx when x tends to a plus is equals to ga. So the gx is continuous at x equals to a. So gx is continuous at x equals to a. Okay. Now we will now check the continuity of gx at x equals to b. So we will proceed in the similar way. Okay, like this. See, how will you check the continuity of gx at x equals to b? So the limit of the limit of gx, when x tends to b minus, that means the value of x is less than b. So less than b, the gx is equals to this. Okay, that is, it is equals to x tends to b minus. It is a definite integral of ft dt to the limits a to x. Now here I will put the value of x, I will put b. Okay, so this is equals to definite integral of ft dt to the limits a to b. Okay, and the limit of gx when x tends to b plus. So b plus, so when the x is greater than b, so what is the value of gx? The value of gx is equals to this. So this is equals to limit of x tends to b plus, it is definite integral of ft dt to the limits a to b. Okay, so this is equals to, now there is no term of x. Okay, so this is equals to the definite integral of ft dt to the limits a to b. And what is gb? So gb is that when the x is equals to b. So when x is equals to b, it is equals to this function. That is, in place of x you will put b. So this is definite integral b a, okay, ft dt. So what we are seeing, that the limit of gx as x tends to b minus is equals to a definite integral of ft dt to the limits a and b, and same is the limit of gx when x tends to b plus, and that is the same as the value of gb as well. Okay, so these three values are equal. Okay, so the result is gx is continuous at x equals to b. Okay, now we will check the differentiability of gx at x equals to a and x equals to b. Okay, now see how I will check the differentiability of gx at x equals to a and x equals to b. Now see here, g dash x, that is the ddx of gx when x is less than a. So when the x is less than a, the gx is equals to 0, that is a constant function. Okay, so the differentiation of a constant function is 0. So g dash x is equals to 0 when x is less than a. Okay, and the differentiation of gx when x is between a and b including both, it is equals to g dash x will be equals to dd x, it is equals to d dx of the definite integral of ft dt to the limits a to x to the limit a to x when what? When if a is less or equals to x is less or equals to b. Okay, so how we differentiate this? Okay, definite integral. So it is differentiated like this. Here for t I will put x. Okay, fx into dd x of x. Okay, that is the upper limit, minus this will be fa. Okay, in place of t I will put a and ddx of the lower limit. Okay, so ddx of a, and ddx of x is 1 and the ddx of a, that is a is a constant function, so its ddx will be 0. So this will become fx into 1 minus fa into 0, which is equals to fx. Okay, so the g dash x is equals to fx when if a is less or equals to x is less or equals to b. Okay, and similarly I will find out the ddx of gx, okay, when x value lies is greater than b. Okay, so g dash x will be equals to dd x of the definite integral of ft dt to the limits a to b, okay, when if x is greater than b. So what is the ddx of this? Okay, so in place of t, first I will put the upper limit, so this will become ft into dd x of the upper limit, that is b, minus here in place of t I will put a, that is fa into dd x of ba. Okay, so a and b are the constant terms. Okay, so their ddx will be equals to 0. So this will become fb multiplied with 0 minus fa multiplied with 0. So this ultimately will be, the whole value will be 0. Okay, so the g dash x will become 0 if x is greater than b. Okay, so now the left hand limit, so the left hand limit of gx, so the left hand derivative, sorry, the left hand derivative of gx at x equals to a. So what will be the when the value of x is less than a? So the g dash x is equals to g dash x is equals to 0. Okay, and the right hand derivative of gx at x equals to a, that is the value of x is greater than a. So what is the ddx of gx? It is equals to fx. So here x I will put the value a. Okay, so this is equals to fa. So the left hand derivative at x equals to a is 0 and the right hand derivative of gx at x equals to a is fa. So fa is not equals to 0. Okay, so the left hand derivative of gx at x equals to a is not equals to the right hand derivative of gx at x equals to a. So therefore gx is not differentiable at x equals to a. Okay, so the gx is continuous at x equals to a, we have already showed it, but it is not differentiable at x equals to a. So now I will check the differentiability of gx at x equals to b. Okay, so now the left hand derivative of gx at x equals to b. So that means the value of x is less than b. Okay, so when the value of x is less than or equals to b, the g dash x equals to fx. So that is, in place of x I will put down b. So that is equals to fb. Okay, and the right hand derivative of gx at x equals to b, that means the value of x is greater than b. So when the value of x is greater than b, so g dash x equals to 0. So this is 0. Okay, so what we are noticing here, that is the left hand derivative of gx at x equals to b is not equals to the right hand derivative of gx at x equals to b. Okay, this is 0 and this is b. So gx, so the result is gx is not differentiable differentiable at x equals to b. So what is the result we have got? We have got that gx is continuous at x equals to a but not differentiable at x equals to a. Gx is continuous at x equals to b but not differentiable at x equals to b. So the options A and B are saying the same thing. So the option A is saying that gx is continuous at x equals to a and not differentiable at x equals to a. So the option A is correct. Okay, and the option C says that gx is continuous at x equals to b but not differentiable at x equals to b. Okay, so the C option is also correct, and B is saying that the gx is differentiable on R. So it is not differentiable on in full R because it is not differentiable at x equals to a and x equals to b. So it is not differentiable for all x equals to R. Okay, so the option B is incorrect, and option D says that the gx is continuous for a and b both, but differentiable either at a or b but not both. So we have noticed that it is not differentiable at both a and b. So the option D is also incorrect. So the option A and C are correct options. Okay, so thank you. I think that you must have understood the problem. Okay, thanks.